In this lecture, we are going to be talking about Hamiltonian circuits. Go ahead and take a look at the overview for this video. This diagram defines the relationship between Hamilton paths and circuits. While both are routes that have to touch every vertex without touching the same vertex again, circuits have to be complete by starting and ending at the same location, while paths do not necessarily have to begin and end at the same location. You can't determine if a graph contains a Hamilton circuit just by looking at it. The way to find out is by trial and error. By starting at vertex A, we can follow a line to C, D, B, E, and finally back to A. This is a Hamilton circuit as it touches every vertex without having to repeat, and it starts and ends on point A. In order to find the number of Hamilton circuits in a complete graph, we use the formula n minus 1 factorial, where n is the number of vertices. In this example, with 5 vertices, we subtract 1 from 5 and then find 4 factorial, which leaves us with 24 Hamilton circuits. Be careful, because the number of unique Hamilton circuits is actually half that number, so there are 12 unique Hamilton circuits. Hamilton circuits are well known because of the traveling salesman problem that they solve. Imagine this scenario. A salesman needs to travel to 4 different cities and get 4 different sales pitches before returning home. He maps out the cost of each flight going from city to city. The cities are represented by the vertices, with his home city being the reference point where he starts. And the flight paths are represented by the edges connecting the cities, which are measured by the weight of each edge. The weights in this case are the cost of each flight path. The goal is to find the cheapest flights that touch every city while starting and arriving back at his home city. To do this, we have to find the Hamilton circuit with the lowest weight. The brute force algorithm is one method to solving TSP. Take a look at it before we give an example. Alright, let's take an example problem together. NASA has located 3 black holes and is sending their futuristic spaceship to gather information at all 3 sites. Suppose the spaceship starts at home base located at vertex A and needs to reach all 3 black holes before reporting back to home base. What is the fastest route the spaceship can take? Alright, so our first step is to find the number of unique circuits. Let's use the formula n minus 1 factorial to find the number of circuits. We plug in 4 for n, as that is the number of vertices. 4 minus 1, which leaves us with 3 factorial, and that gives us 6 possible vertices. 6 possible Hamilton circuits. But only half of them are unique, because the other half are just reverses of the unique ones. So we divide 6 by 2, and we end up getting 3 unique circuits. Now let's find those 3 unique circuits and their weights. So let's find the first circuit. If we start at A, which is home base, we can go to B, and that would add 4 to the weight, as you can see here. And from B, we can go to C, and that would add 3. And from C, we can go to D, adds 5. And D back to A to complete the circuit, and that would add 6. If we total it up, it'll leave us with 18 as our weight for circuits A, B, C, D, A. So circuit A, B, C, D, A has a total weight of 18. Note that if we went in reverse from A to D to C to B and back to A, that would give the same weight, and therefore it's not unique. Now let's find the other 2 circuits. So let's start from A, and we'll go to B. That will be plus 4. And from B, let's go to D, and that gives us plus 3. And from D, we'll go to C, plus 5. And for C, we'll complete the circuit and go back to A, plus 8. If we total that up, we'll get a weight of 20 for circuits A, B, D, C, A. And to make sure not to count this reverse circuit, finally we can find the last circuit where we can start from A as our home base. We can go to C. That gives us plus 8 for our weight. And from C, we can go to B, plus 3. And from B, we can go to D, plus 3 again. And for D, we can complete the circuit by going back to A, plus 6. That circuit has a weight of 20, so circuit A, C, B, D, A has a weight of 20. By comparing all the circuits, we can see that circuit A, B, C, D, A has the least weight, and therefore it will be the optimal path to take. If you are ready, go ahead and take the quiz that's attached to this video. Thank you for watching this lesson on Hamiltonian circuits.